Hello everyone, good day. So I'm Precious Walalugay from 2base AB Section G. So for today's video, I'll be reporting my part in our lesson. So let's proceed. So we are here now at Module 1, Introduction to Economics in the Scope of Managerial Economics. So Lesson 3, Economic Optimization. So the learning outcomes can be able to explain optimization process by a firm, compute optimal solution problems using the concept of derivatives and rules of differentiations. Topic is economic optimization. So what is economic optimization? Well, economic optimization including competitive production cost is the ultimate goal of sound reservoir management. So it involves building multiple scenarios or alternative approaches in order to arrive at the optimum solution. Economic optimization is the process of making a trading system more effectively by adjusting the variables used for technical analysis. The trading system can be optimized by reducing certain transaction cost or risk, or by targeting assets with greater expected returns. So let's proceed. Optimization with calculus. So now we apply the rules of differentiations to the process of optimization. So first is we determine the point at which a function is a maximum or minimum. Then after, we distinguish between a maximum and a minimum. Then so so let's proceed to determining a maximum or a minimum. So optimization seeks to find the maximum or the minimum value of a function. For example, a firm may seek to maximize its sales, minimize the total cost, and eventually maximize its profits. Suppose that total revenue function is given by let's have some example here. Let's see this example here. The total revenue is equals to 200Q minus 200Q, and the derivatives over the total revenue is equals to 200 minus 400Q. Setting the derivatives to the total revenue is equals to 0. So we have to get the 200 over the minus of the 40Q. So therefore, the quotient is equals to 5. That this minimum means the least you can do of something. This means that for the total revenue function given above, the total revenue function has 0 slope at 5 units of output produced. For a function to be at its maximum or minimum, the derivative of the functions, that is the objective function, must be 0. So kailangan siya 0 para makuha na to ang total revenue or the quotient. So this is equivalent to the point where the curve has 0 slope. Yes. For example here, as I explained earlier, if the minimum amount of the dollars you must pay for something is 7, then you cannot pay $6 or less. You must pay at least 7. So but you can do more the minimum, but no less. Maximum means the most you can have of something. Yes. So let's proceed to distinguishing between a maximum and a minimum. So minimum means the least you can do of something. When the derivative slope of a function is 0, we find its maximum or minimum point. This is the first order derivative. To distinguish between a maximum and a minimum point, finding the second derivative is necessary. So suppose, let's see this example here. Suppose that there's a firm has a following profit function. So the total revenue is equals to 200q minus 200q squared. So the derivative over times total revenue is equals to 200 minus 40q, and the derivative of the 2 is suppose the firm that has a following functions need to equal to 0 and solve for the finding the x and y. So to distinguish between a maximum and minimum point, finding the second derivative is necessary. So we have to find the second derivative. So here the total revenue function has 0 slope at 5 units of output, since the derivative squared times total revenue over the derivative q squared is equals to minus 20. This total revenue function reaches a maximum at q equals to 5. So let's proceed to optimization involving multi-variable functions. To maximize or minimize of multi-variable functions, first we find the partial derivatives noted by the symbol of this of the dependent variable, say profit. This is the symbol of a profit with respect to each of the independent variable, say price and advertising. So then we set all first order partial derivatives equal to 0 and then solve the resulting set equations simultaneously for the optimal value. So we have here the rules for determining the partial derivatives are the same as those discussed in the previous section. Note that the partial derivatives measure the marginal effects of each of the independent variable to the dependent variable. So suppose that the firm has the following profit function. So we have here example of profit 100x minus 2x squared minus xy minus 3y squared plus 100y. So we set as a symbol of ax and a squared, ay equal to 0, and solve for x and y. So after this, we have here at the symbol of this ax is equals to 100 minus 4x minus y is equals to 0. After this solve stimulously by multiplying the first of the above expression by uh, minus 6 or negative 6, rearranging the seconds and adding, we get. So let's proceed here. Minus negative 600 plus 24x plus 6y is equals to 0. 100 minus x minus 6y is equal to 0 over negative 500 plus 23 equals to 0. So therefore the firm maximize when it sells 21.74 units of commodity X and 13.04 units of commodity Y by substituting these values into the profit functions above. The total profit would then be at 2,249 and 25 centavos. So that's all for today. Thank you.